Hello, everyone. I wanted to do a quick video for you to help with finding slant and horizontal asymptotes. So we went through the process really quickly in class today. You're going to create your end behavior fraction that is your leading term on top divided by your leading term on the bottom, and you're going to simplify that. And then you're going to think about what happens to that as x goes to infinity. If your end behavior fraction simplifies to a number or a number over something with x's in it, you've got a horizontal asymptote. If it simplifies to a number, y equals that number is going to be your horizontal asymptote. If it simplifies to a number over something with x's in it, y equals 0 is your horizontal asymptote. If your end behavior fraction simplifies to an x or a number times x, then your rational function acts like a line at the end. That means you have a slant asymptote, and to find it, you're going to perform polynomial division, and y equals your quotient is the equation of your slant asymptote. And then finally, if your end behavior fraction simplifies to something that looks like x to the second or x to an exponent higher than 2, then you don't have horizontal or slant asymptotes. You have polynomial end behavior, and you will find your end behavior just like we did before. So you'll do as x approaches infinity, what does y do? And that's going to depend on whatever your end behavior fraction does. And then as x approaches negative infinity, whatever happens to your end behavior fraction as x goes to negative infinity, that's what y is going to do. So you'll perform polynomial end behavior with your simplified end behavior fraction, just like we did on Monday. Okay, so let's do some examples here. So we want to find the end behavior of each of these. And while we do that, we will identify any horizontal or slant asymptotes that we might have. So number one, r of x equals 5x over x squared minus 3x minus 4. We're going to start by finding our end behavior fraction. Leading term on top is 5x. Leading term on the bottom is x squared. Simplify that. And we get 5 over x. So as x goes to infinity, what happens to 5 over x? 5 divided by a bigger and bigger and bigger number. You can put numbers in your calculator and see what happens. But as x gets bigger and bigger and bigger, this thing is going to go to 0. That means this has a horizontal asymptote, and our horizontal asymptote is y equals 0. All right, number 2. We found to find our end behavior fraction, we will do the leading term on top, which is 5x squared, and we're going to divide by our leading term on the bottom, which is x squared, and we are going to simplify that. 5x squared divided by x squared is just 5. Now, as x approaches infinity, 5 goes to 5. It doesn't change. There's no x's in there. And so that means we have a horizontal asymptote, and our horizontal asymptote is y equals 5. Basically, if your end behavior fraction goes to a number as x goes to infinity, you've got a horizontal asymptote. If your end behavior fraction looks like this, like it did in number 1, as x goes to infinity, it goes to a number, it goes to 0. So we had a horizontal asymptote in both of those cases. Number 3, our end behavior fraction. We're going to start with that to find the end behavior of this rational function. And we're going to do the leading term on top, 5x to the 4th, divided by our leading term on the bottom, which is x squared. And we're going to simplify that. And we get 5x squared. That means as x gets big at our ends, my function's going to look like 5x squared. Now, this is a polynomial, which means this thing is going to have polynomial end behavior. And that means we are going to find our end behavior just like we did on Monday. So as x goes to infinity, I'm going to plug in a huge positive number for x, and I'm going to have 5 times a huge positive number squared. When I square a huge positive number, I get a huge positive number, and then I need to multiply that thing by 5, and I'm still going to have a huge positive number. So that means as x goes to infinity, so does y. And then as x goes to negative infinity, I'm going to plug a huge negative number in for x in my end behavior fraction. And if I square a huge negative number, I get a big positive number. I'm going to multiply that thing by 5, and I'm still going to have a big positive number, which means I'm going to go to infinity on both sides. And this thing has polynomial end behavior. It looks like this. We don't have a horizontal or slant asymptote. So this has no horizontal asymptote or slant asymptote. All right, number 4. Our end behavior fraction here is going to be leading term on top, which is x squared, divided by leading term on the bottom, which is x. And that simplifies to x. Okay, so again, this is a polynomial. We're going to have polynomial end behavior, but because we have just an x here, that means that at the ends of the graph, this thing is it's gonna look kind of like x. It's gonna be linear at the ends. That means we have a slant asymptote. And since we have a slant asymptote, we got to find it. In order to do that, we're going to perform polynomial long division on this thing, which means we're going to take the top and we're going to divide by the bottom. And you're not going to touch this at all. You're going to take the top as is, and you're going to divide by the bottom as is. And you're going to perform polynomial long division on this. Leading term inside divided by leading term outside gives us an x. And you're going to take that x and multiply by the whole divisor. And so we're going to get x squared minus 2x. After you multiply, you're going to subtract the whole thing. X squared minus x squared cancels. Negative 3x minus a negative 2x becomes negative 3x plus 2x, which is negative 1x. And then this comes down, so we have a plus 1 here. All right. Leading term inside is divisible by leading term outside, so we got to keep going. My leading term inside is negative 1x divided by my leading term outside, which is x. Negative 1x divided by x is negative 1, so that's what comes up here. I'm going to take that negative 1 and multiply by my whole divisor, and when I do that, I get negative 1x plus 2, because I distribute that negative 1, and then I'm going to subtract that whole thing. Negative 1x minus a negative 1x becomes negative 1x plus 1x. Those cancel. And 1 minus 2 is negative 1. All right, so I went quickly through that polynomial long division. If you're still rusty on polynomial long division, there is a video for that specifically up on D2L. You can use that to help you with this. So we've performed polynomial long division. Your slant asymptote, your equation is going to be y equals your quotient. Now the quotient is the thing up here, and so y equals x minus 1. That is the equation of my slant asymptote. It's going to be y equals whatever your quotient is after you do that division. And that's our slant asymptote. All right, so hopefully that helps with the horizontal and slant asymptotes. I'm going to make another video for graphing rational functions. Basically, to graph rational functions, you're going to find holes, vertical asymptotes, and x-intercepts, which we did in class today. You're going to find your horizontal or slant asymptotes, just like we just did, using your end behavior fraction. And then you're going to put all that stuff on a graph and connect your dots. So I'm going to make another video for that with some examples for you to help. And just a fair warning, with the finding the horizontal and slant asymptotes, Alex is going to take a slightly different approach than I did. It's going to give you rules about the degree of the numerator and the degree of the denominator and how they work together, which is pretty much equivalent to the way that we've been doing this with our end behavior fraction as well. You're comparing leading terms when you compare those degrees. So hopefully that helps. You can really use my way or Alex's way, whatever works best for you. Let me know if you have any questions, and I will see you next time.